Hello, this is Pascal Triangle 2. Crazy, crazy that they put this as easy. I hate these kind of problems and you'll see why. So we're given an integer row index and we return the row index row of the Pascal's triangle. And Pascal's triangle, each number is a sum of two numbers directly above it as shown in this GIF. So yeah, just like the original Pascal's triangle, it's basically the same thing, except at the end of creating your triangle, you're just going to be returning that row, right? But there is a trick to this one for the most efficient algorithm, and I'm going to try to explain it the best I can. So if you were like me, you tried to find some kind of pattern with Pascal's triangle. I noticed, obviously, that the ones are in the outer layer, but also, depending on what row you were in, we could also get the next number. So this is row number 2. So after you insert that one, you can have 2 here. And then after you insert this one, you'll get 3 here. After you insert this one, you'll get 4 here. So I'm like, okay, there has to be some kind of pattern to this. And if you saw my attempt, you'll see what I tried to do and it didn't work out. But essentially what I found out is that this Pascal's triangle is just a tool to get binomial coefficients. What is a binomial coefficient, you ask? I don't know. I said the same thing. But essentially what it is this mathematical formula. You saw that right. This is what it looks like. I hope that cleared things up because it didn't for me. But essentially, it's saying how many ways can we choose k things from n things. Did that clear things up? Because it didn't for me. I had to read it a couple times, but think of it like this. So say we have an apple, an orange, and a turnip. Okay? N is going to be 3 because there's 3 things here. Okay? There's 3 things. All right? 3 things. An apple, an orange, and a turnip. Now in those 3 things, actually what is k? K is anything, any number, right? But we're going to say 0. Let's say k is 0 right now. So we're saying how many ways can we choose 0 things from 3 things? How many times can we choose 0 of these, right? The answer is 1. You can only choose 0 of them. That's the only option you have. If you want 0 things, you choose 0 of them. That's it. That's 1. Okay. So let's say you want 1 thing. How many ways can we choose 1 thing from 3 things? We can choose an apple. That's 1. We can choose an orange. That's 2. Or we can choose a turnip. That's an ugly 3. Boom. All right. I think you get the picture, right? Let's say how many ways can we choose 2 things from n things? I know it's going to get a little tricky. You can get an apple and an orange, right? 1. Apple and a turnip. 2. Orange and a turnip. 3. Is that it? I think that's it. Yeah. Okay. And then lastly, how many times can we choose 3 things? Oh God, it's getting hot in here. An apple, an orange, and a turnip. 1. What does this look like? Tell me what this looks like. Please tell me what this looks like. It looks like the 3rd row in Pascal's triangle. Okay, I know I said the 3rd row, but it's obviously the 4th row. But in programming, it's like 0, 1, 2, 3. That's what I meant. That's the number I meant. The 3rd index of this row. This is a ridiculous problem. It's just ridiculous. So yeah, that's a binomial coefficient. Pascal's triangle is just a tool to get these numbers. That's all it is. Okay. And I have no idea how you were supposed to be able to get this, by yourself without looking it up, but that's it. And so n in this case is going to be the row that we're at. And then k is going to be the index of that row. Okay. 0, 1, 2 are the k's. 3 is the n here. I hope that makes sense. I genuinely hope that makes sense. So if you're curious, this is what the you know, original Pascal's triangle kind of approach would look like for this problem. You just return the last row, but I'm going to walk through how you can do the binomial coefficient way, right? And so we know row index is the row that we're working on. So we're going to need to iterate through that row. We're going to have I variable. We're going to say I less than the row index, right? So it'll be 0, 1, 2, 3. So on the third row, look at this on the third row. Yeah, we only want 3. I had an off by 1 error in the drawing, I think. But yeah, I think you get the picture. So I less than 3, that was 3 indexes. Then we'll do I plus plus. Okay. Okay. So this is where we do the algorithm. We're going to want to have an array, right? And this array can start with 1, actually, because we know that the edges of the rows are 1. And, oh, we didn't even initialize this to a number, but this can also start at 1 because this is already filled. So 0th index is 1. So we're going to want to do the binomial coefficient algorithm. What that looks like is this. And I'm not even going to try to explain why this works. Okay, here it is. Do you get it? Cool, cool. Essentially, I don't even know why I'm going through this. I'm not going to remember it, and it's not going to be helpful, but here it is. Here I am. Here I am. This is the official equation for the binomial coefficient, right? This is the binomial coefficient, and this is the formula to get it. N factorial, k factorial, n minus k factorial. I think that's what factorial is. Anyways, they basically were able to derive this formula from it, which is the exact same thing, or is the exact same result, as you can see on the left-hand side. And this is what essentially what Pascal's triangle is, right? We are getting, division. We are getting the result of the previous, we're getting the result of the previous binomial coefficient, right? K minus 1 here. And we're multiplying it by this formula. Look, you can't tell me to explain this to you. I don't know. But as you can tell, n, row index, k, I, plus 1, k, k. Dude, my hands are tied. I don't know. I hope this helped. Thank you.